Okay, this is section 5.3 from MathLinks 9 on adding and subtracting polynomials. So as we go through this, make sure you have your sheet out that you did the work and copy down the answers. This video is available on YouTube, so if you don't actually get it all copied out, just make sure you go home over the long weekend and watch the video again, press pause, and copy down the things you missed as we went through it the first time. But make sure you're listening and don't make Miss Lawless have to blue card you. That would be awful. Question 5 says, which addition statement does the diagram represent? Now remember, what we learned before is what we have here are the difference between this tile, which is going to be a negative x squared, and this tile, which is going to be an x squared. All right? So if we look at the top polynomial, that's right here, we have two negative x squareds, or negative 2x squareds, and, remember plus sign could be and, we have 3x. So if I put that in brackets, that's going to be my first polynomial. So right off the bat, if I look at B and C, both of those have that particular term, polynomial is the first term. So therefore, I can eliminate this one because I know that's not going to be the one. So now I have a 50-50 chance of guessing it correctly. The second polynomial at the bottom is 3x squareds, which is the first one, those done, and a negative x. Now some people might think it's like, well, 3x squared and a negative x. But remember, adding a negative is the same thing as just subtracting a positive. So what we're going to write it as simply subtract x. So therefore, when I look at that, I can eliminate B. And my answer, therefore, is C. Question 6 says add the polynomials. So you're given 4 questions, A, B, C, and D. The first one, if I was to draw it first, I'll draw the first one just to show you what it would look like. So if I'm adding them, I could draw 3 x's and a negative 4. And to that, I could add 2 more x's and a negative 3. Now remember, when you're adding polynomials, it's the same thing if I was to reword it or gather like terms. In 5.2, we learned how to gather like terms, and really adding polynomials and gathering like terms are the same thing. So if I look at this, these 3 x's and these 2 x's is going to leave 5 x's, which is going to be this one and this one. These negative 4 and this negative 3 is going to make negative 7. So my answer for those two binomials added together is going to be 5x minus 7. For B, we have negative a squared minus 3a plus 2 plus negative 4a squared plus 2a. So for this one, I'm not going to draw it, but what I am going to do is show you that an easier way to do it is to box up your terms with their plus or minus sign, because that's going to act as your positive or negative sign. So here I see I have 5 terms. The first terms you should always gather are the terms that have the highest degree, in this case the a squareds. So I have a negative a squared and a negative 4a squared, which is going to be a negative 5a squared. A negative 3a and a positive 2a. Really what you want to do is keep your variable and add your coefficients. So a negative 3a and a positive 2a is going to be a negative 1a. And remember, you don't need a negative 1 coefficient, so we're just going to call it a negative a instead of a negative 1a. And finally, the constant of plus 2 is by itself because there is no constant to gather it with, so we just have plus 2. For your third question, C, we have 5p plus 5 plus 5p minus 5. Box it up. I have 4 terms. This 5p and this 5p are going to make 10p. This positive 5 and this negative 5 are going to make a 0 pair, leaving you with nothing. So your answer for C is simply 10p. And for D, I have 1, 2, 3, 4 terms. Box them up. A 2y squared, a negative 15, a 6y, and a positive 9. 6y and 2, oh sorry, I did that wrong. Your 6y squared is the only term that has y squared. Remember, like terms have to have the same variable and the same exponent. So 2y squared is going to remain as itself. Plus 6y is going to remain by itself because there are no other y terms. And a negative 15 and a positive 9 is going to make a negative 6. Those are your answers for question 6. Question 7 says perform the indicated operation and simplify by combining like terms. So again, we have addition here. So a negative 3x and a positive 6x is going to be a positive 3x. And a plus 4 will be your answer for that. Only 3 terms. A 3n and a negative 4n is going to be a negative 1n. but remember we don't write a -1 coefficient, so it's simply going to be a -n, and a -4 and a +7 is going to make a +3. A +2b squared and a -1b squared is going to make just a b squared, and a -3 and a +2 is going to make a -1. And finally, 5a squared and -4a squared, combine the coefficients of -4 and a +5 is going to be a +1 or just an a squared. A -3a and a +2a is going to be a -1a or just -a. And a +2 and a -3 is going to be a -1. So remember, Ms. Lawless, as you're going through this, if the kids need a little bit more time, you can press pause and just have them copy it down if you'd like. There's no need to speed through this too quick. I know I'm going pretty fast. If you want to go back and press pause. I'm sure, Ms. Lawless, if your computer skills aren't good enough, one of these fine young ladies and gentlemen will help you, show you how to fast forward and pause. Question 8 says, what is the opposite of each expression represented by the diagram? So the first thing I need to do is know that this is 3x minus 1. And if we're asking for the opposite, what we need to do is say that each of these terms have to be the opposites. The opposite of 3x will be -3x, and the opposite of -1 will be +1. This is a -x squared plus 2x plus 3. So its opposite will be a +x squared, a -2x, and a -3. Let the big square represent s squared, and let the rectangle represent x, and let the purple thing represent 1. The same diagrams in yellow that represent negative qualities. I don't know why they're doing this, but anyway, what's the opposite? So the opposite would be a solid and a white. Two opens and a solid are your opposites. Question 10, what's the opposite of each expression? So the opposite of -9x is a 9x. The opposite of 5d plus 6 is -5d minus 6. And the opposite of -2x squared plus 3x minus 5 is +2x squared minus 3x plus 5. Now, an interesting thing, if I took a 9x and combined it with its opposite, I will always make 0. So anytime you have a polynomial, for example, 5d plus 6, and you add to it its opposite, you will always end up with nothing, because these will make a 0 pair, and these will make a 0 pair, and you'll be left with nothing. So the interesting part about why are we doing these opposites? Well, the opposites are there so that if you wanted to make 0 pairs, you could. Question 11, what is the opposite of each expression? So again, a little redundant, but -3x plus 7, -4g squared plus 4g minus 2.5, and -v squared minus 8v plus 1 is its opposite. Which of the following represent the opposite of 2x squared minus, so rather than look for the picture, I'm going to say, well, the opposite of that would be -2x squared plus x, so I'm really looking for this picture. -2x squared minus x, so it's not that, because that's a minus x, not a plus x. It's not this one, because that's a positive 2x squared. I'm looking for a -2x squared. So the answer is B, a -2x squared plus x is the opposite. Question 13, draw a diagram to model the subtraction set. So I'm going to show you how to do this, and if you don't know how to do it at the end of it, that's fine, don't worry about it. It's not really that important that we can diagram it, but I'd like you to understand it if you can. So take a moment here and just follow along. Ms. Lawless will press pause if you need to. So this binomial right here, -3x squared plus 4x, is represented by what I have. Now from that, I have to take away -2x squared and a -x. So let's see what happens when I do that. So if I take away -2x squared, I'm going to put lines through that to show that I am taking away -2x squared. Another way to do it would be simply to take it like this and put an arrow away from it, or an even better way is to simply take away -2x squared. So let's do it that way instead. I also have to take away a -x, but if I look at my picture here, I don't have a -x, I just have 5x's. So the important part here is understanding what this value is here. Now this is a algebraic zero pair. That's a positive x and a negative x, and its value is nothing. So if I understand this is nothing, and I understand right here I have negative x squared plus 3 or plus 4x, if I bring this up into here, I still have not affected the value of all of this. This is still negative x squared plus 4x in terms of its value. But by bringing in that zero pair, what I've allowed myself to do now is to take away a negative x. And by taking away a negative x, I actually add a positive x to it. And I end up with, this is my answer, negative x squared plus 5x. So the answer from a modeling perspective is negative x squared plus 5x. Okay? Now, what I could have done probably, if this question was given to me, I would have never actually modeled it, but what I would have changed that to addition and used the opposite of each, and then I would have gathered like terms. Negative 3x squared and a positive 2x squared would have been a negative x squared. A positive 4x and a positive 1x would be 5x, and I would have ended up with the same answer, but without modeling. Question 14, simplified by combining like terms. So here we have subtraction of polynomials. And the rule we talked about, like if we had an integer question in grade 7, and we give you this one, you could have had 2 negatives, and you could have taken away 3 negatives by putting in that zero pair, and you would have taken away 3 negatives, and you would have ended up with a positive 1 answer. That's what you learned to do in grade 7. But you also learned to keep flip change, and that will always give you the same answer. So in this case, this would be a positive 1. However, that same idea applies to polynomials as well. So you can change the subtraction to addition, and instead of using 5x minus 1, we could use the opposite of each term. So instead, I can use this. When I gather like terms, a 2x and a negative 5x will be a negative 3x, and a negative 3 and a positive 1 will be a negative 2. In the second example, keep the first polynomial as is. Don't change anything in that. Change it to addition and use the opposite of everything in the second polynomial. In this case, a binomial, everything becomes its opposite. Negative 3b squared and negative 2b squared, it be a negative 5b, oh, that's a D. Turn on my letters. Negative 5b squared, a negative 5b and a negative 4b make a negative 9b, and your answer would be negative 5b squared minus 9b. Keep the first polynomial, change to addition, and use the opposite of every term in the second polynomial. Now this time I have a 5 first. I'm not going to gather my constants first. I'm going to gather my terms with the highest degree, which happen to be my w's. So this is a negative 6w and a positive 3w. And when I combine those two, I'm going to end up with a negative 3w. A positive 5 and a positive 2 make a positive 7. Now if you had 7 minus 3w, that's the same value, but you should always rearrange them in descending degree of terms. So you should get that instead. And finally, keep the first polynomial, change to addition, and use the opposite. And m squared is going to be the first thing we gather, even though the first polynomial doesn't have that. I'm going to gather my m squares to give me negative m squared, because there's only one of them. There's only one of those m's, and it's a positive m, so I'm going to put a plus m, not just m, a plus m. And a negative 7 and a positive 7 make a zero pair. So for D, the binomial plus the binomial gives you a binomial with no constant. Question 15, again, subtract. So keep the first polynomial, change to addition of the opposite. 8c and 5c make 13c, and minus 3 is your constant. Keep the first trinomial. This time we have a trinomial instead of a binomial. Change to addition, and use the opposite of every term in the brackets. Gather your r squareds first, your highest degree. A negative 3r squared and a negative r squared make a negative 4r squared. Negative 5r and positive 2r make negative 3r. And a negative 2 and a negative 4 make negative 6. Keep, flip, change. A y squared and a y squared make a 2y squared. A negative 5y and a negative 2y make a negative 7y. And finally, the last one, keep, flip, change. 6j squared and 2j squared make 8j squared. And negative 4j combines with no other j's in the second polynomial, so it's negative 4j. And a positive 3 and a positive 5 make a positive 8. Your next question, 16, says a triangle has the dimensions as shown. What does x minus 3 plus 3x minus 2 plus 2x plus 5 represent? It represents the perimeter of the triangle, or the distance around the outside of the triangle. Simplify the expression in part A. So we're adding them, so we don't need to keep flip change. We just have to add them. An x and a 3x and a 2x makes a 6x. A negative 3 and a negative 2 make a negative 5. A negative 5 and a positive 5 make a 0. So your answer for the simplification is just 6x. And part C, if x is a value of 5, what is the perimeter of the rectangle? So there's two ways to do it. Since this is the simplified perimeter, you could simplify, or you could substitute 5 for the x, and the perimeter would be 30 units. Another way you could do it is simply take each of the sides and substitute 5 into it. So instead of being 5 minus 3, this whole side here, I'm going to put it inside there, will be 5 minus 3, which is 2. This side here would be 3 times 5 minus 2, which is 15 minus 2, which is 13. And this side here is 2 times 5 plus 5, which is 10 plus 5, which is 15. And a 2 plus a 15 and a 13 still make a 30 units. Question 17 says, copy and complete the addition pyramid. Find the values of any box by adding the expressions of the two boxes immediately below it. So this box right here will be made up of this binomial plus this binomial. So all I have to do is add a 2x and an x to get a 3x, and a negative 1 and a positive 3 to make a positive 2. This one here will be made up by this binomial and this binomial, or an x plus a 3x is 4x, and a positive 3 and a negative 2 make a positive 1. And finally, this box here will be this binomial plus this binomial, or 4x, because the minus 2 and the positive 2 cancel each other out. I continue on by adding the two boxes below it, so this box will be made by this and this, or 7x plus 3. This plus this will make this, which is 8x plus 1. And finally, this one will be the one below it, which is 15x plus 4. Question 18 says, in Langley, British Columbia, you can rent a backhoe for $399 a day and a bulldozer for $550 per day. It costs $160 round trip to move each piece of equipment back and forth to the job site. Write an expression for the total cost of renting a backhoe before tax. Okay. Please include transportation to and from the job site. So what does your variable represent? So x is going to represent the number of days you rented for. So the first thing I'm going to do is define my variable, number of days rented. Now, if it costs $399 to rent that backhoe, it is going to be $399 multiplied by the number of days. So I'm going to use $399 as a coefficient in my algebraic expression. 399 multiplied by the number of days plus that $160 is going to cost for a round trip to get the backhoe there and back, no matter how many days you rent it for. So for example, if I rented it for 2 days, it would be $399 times 2 days plus the $160 to get there, and I could figure that it was being, whatever number. But this expression is the algebraic expression that represents the cost for the backhoe. Now for B, the cost of the bulldozer is almost identical, except instead of $399 a day, it's $550 a day plus $160 round trip. So there's the polynomial for B. And finally, C, not finally, but it says, what is an expression for the total cost of renting both a backhoe and a bulldozer? Well, here we take the cost of the backhoe plus the cost of the bulldozer. And that would be the expression for that. And finally, D says, what is an expression for the difference Oh, sorry, actually I can simplify this. So now that I have this to rent both of them, I would gather those two like terms. That would be $949, or 949 multiplied by the number of days, plus $320 to get the both the bulldozer and the backhoe to and from the job site. And finally, D, what's the difference between the cost of renting a backhoe and the bulldozer? Give your answer in simplest form. Well, if we say the cost of the backhoe, or is it the bulldozer, is this. Take away the cost of the backhoe, which is this. Now that I'm subtracting, that's what difference means. Difference means subtraction. I'm going to keep the first polynomial, change to addition, and use the opposite in the second. So 550 plus negative $399 is 151. X, and the positive 160 and the negative 160 are going to cancel each other out. So the difference in renting a backhoe and a bulldozer is $151 per day more. This means $151 per day more to rent a bulldozer.